Section B7, Local Urban Flooding Initiatives. Couple housekeeping notes here before we start. For those of you who were involved earlier this morning, you know you can put in questions. There'll be a little Slido bar right there. Type in your questions, submit, and we'll go through from there. And when we get to the question and answer, that's what we'll be utilizing. If you see a similar question, rather than retyping a question, just put a thumbs up on it, and that'll rank it, and that'll make it more likely that I'll ask it, because if there's a question that a lot of people want to hear about, that's be the one that we'll go with. Also, please send questions. Feel free to do it during the presentation. You don't have to wait to the end. We would like to see them as soon as possible so we can get moving with this as quickly as possible. Once this session is over, between sessions, please visit the exhibit hall. There's lots of firms and vendors there that have providing lots of information. You visit with the Flood Science Center, which I'm affiliated with. Check out what we're dealing with, but you can also find an opportunity to get a drawing for a registration discount of $200 for next year's conference. I didn't say it, but my name is Bill Brown with the Flood Science Center at ASFPM. Our first presentation will be Going Digital with Open Channel Stormwater Asset Management in a High Elevation Municipality. It will be with Ed Schenk and Corin Smith with the City of Flagstaff, Arizona. With that, let's start the video.
Thank you for joining us today. My name is Ed Schenk, and with me is Corin Smith. We are both with the City of Flagstaff Water Services Division. Our talk today is entitled Going Digital with Open Channel Stormwater Asset Management for a High Elevation Municipality. Overview of our location. This is Flagstaff, Arizona. We are at roughly 7,000 feet above sea level. We're surrounded by the largest ponderosa pine forest in the world, and Flagstaff is the largest economic center in northern Arizona. We are the home to a public university, Northern Arizona University, and are at the edge of the Colorado Plateau, the physiographic province of southwestern Colorado, southeastern Utah, portions of New Mexico, and northeastern Arizona. And we're also at the edge of the San Francisco volcanic field. Within that volcanic field is the highest mountain in Arizona. You can see it on this picture. Mount Humphrey is a little over 12,000 feet elevation. Just to show you a map of that physiographic province, Colorado Plateau, that's on the left. And then on the right, we have a general geologic map for Flagstaff. So the purplish colors tend to be relatively recent igneous rock, a mix of cinder, basalt, dacite, a little bit of andesite. Tends to be rather fractured, highly permeable rock. The more turquoise blue color is Kaibab Formation, which is mostly a limestone, also highly fractured and also has quite a bit of dissolution features, so it's a karst topography. What does that mean for us as a stormwater division or within water services? What it means is that typically our streams and washes around Flagstaff are dry. They're ephemeral washes. And that's because of the high soil infiltration rate through the area due to the geology, the climate, and then also the vegetation. The ponderosa pine has a high degree of detritus and duff that soaks up rainfall. So this graph we're showing here are two regional curves for bankful cross-sectional area compared to watershed area. This is a typical way of looking at channel function using a traditional Rosgen method. So the red is an Arizona regional curve, the blue is a New Mexico regional curve. The dots that you see here are locations near or within the city in natural areas, and you can see they're lower than the two curves. So what that means is in natural parts of Flagstaff or the Flagstaff area, the channels are undersized. And the reason they're undersized is because there's not much runoff due to that high infiltration rate. So I think I described this already. Our watersheds are historically complacent. That's to say that when it rains or snows, most of that does not come through as runoff. Most of it infiltrates or evaporates. Now what this means is when we have disturbances in the watershed, which might be a wildfire or it could be urbanization, this drastically changes the watershed character as well as the stream behavior. So we start seeing that more flashy behavior that you'd expect with urbanization or a fire. Now this means that we have to manage for both complacent conditions that are coming off of natural areas that are undisturbed, and also for violent watershed conditions. And sometimes these are in the same areas. So you have one sub-watershed that has a very flashy nature, and right next to it another sub-watershed that might be completely complacent. So when we manage this, we have a rather small team here at the City of Flagstaff. It tends to be 5 people. At the moment, we're down a few. You can kind of see the overview of the different things that we do. Within stormwater, the stormwater in Flagstaff actually is a utility, so we get a utility rate. And with that, we oversee a capital improvement program, upsizing channels, culverts, detention basins, retention basins, low impact development, etc. We also have a fairly comprehensive system. You can kind of see some of our assets on the right-hand side there, upper right-hand side. And we oversee that for efficiency, maintenance, cleaning, also putting in master planning and flow modeling, so hydraulics and hydrology modeling. There's a rather large capital improvement project that's been going for, or been planning for the last 2 decades. And that's the Army Corps-led Rio to Flag flood control project. So that is now over $100 million to put most of the Rio to Flag, our largest channel and drainage way, underground through the downtown neighborhood. So we review the plans for that and serve as the owner and manager upon completion of that project. We also administer our FEMA floodplains, which includes drainage investigations and response as part of that. Our open channel maintenance, as well as development review for new development. Flagstaff, like most Western cities, has been growing rather steadily, and during COVID, it's been growing quite quickly. So we do both development review and construction site inspections as part of that. So what we're talking about today is our open channel maintenance program. So historically, this has not been tracked by Stormwater until 2020. This has been tracked by our Public Works Department, a different division, and it's been transferred over to Stormwater directly in the last year. And during this, it allows us to actually do a little QA/QC on our GIS layers and our asset management to make sure that we actually are tracking maintenance in a way that makes sense. So we have 24 miles of channels that we report to FEMA as part of our community rating system. So that is the CRS Activity 540. And then we have another 112 miles of natural channels, minor ditches, swales that are not reported to FEMA and are just maintained within the city internally. So on the right-hand side, you can see a picture of those 24 miles. At the moment, before 2020, we counted as 28 miles. Some of that were redundant or incorrectly labeled, so we reduced that through field verification. And then on the right-hand side here, you can see the other 112 miles of channels, roughly. This is being verified currently as we speak. All right, so here we have some examples of what we're talking about with this open channel maintenance. So up until 2020, when we took over the program, most of these maintenance activities were monitored in Microsoft Excel. So they're in a spreadsheet and they just kind of tracked it as they went. So these are the examples of how we've swapped over to our CMMS. So for this example, you can see on the right, an example of a head cut restoration. So this is a head cut, which is where you have an active stream incision. So a disturbance, the stream starts incising, and that incision process starts moving upstream, so opposite of flow. So we're actually seeing this in process. And here you can see where we widen this out and start laying back the banks to provide for a stable channel configuration. So this is the start of what we call a Zuni bowl, which is a type of head cut mitigation, if you will, provided by using these quasi-traditional methods in the Southwest. Works pretty well in ephemeral areas. So we're laying back the banks here, and Next example here is where we actually re-armor the banks, allowing for water to come in, kind of collect in 2 subbasins before leaving out through 2 check dams. Another example of a typical open channel maintenance procedure. On the upper right, you can see this channel again within the Rio de Flag with about 10 years worth of revegetation. And the bottom left, you can see that same reach with the vegetation removed. So we want at least some vegetation in these channels, obviously for bank stability, channel stability, and to provide some roughness, but we don't want it to be so choked that we are causing flooding conditions or flooding hazards elsewhere in the watershed. And moving on, I'm going to hand the presentation over to Corinne, and she is going to start talking about the meats and bones of what we're doing here with the CMMS system, our asset management here at the city.
Thanks, Ed. So my name is Corinne, and I am the Information Systems Administrator for City of Flagstaff Water Services. So I work with the SCADA and IS team. So I work with the GIS, CMMS asset management, as well as IIoT field devices. So our division or section is unique because we have our own GIS section, whereas we have a GIS for the entire city hall that includes anything but water services. So like our community development, parks and recreation, sustainability, etc. So for those who may be unfamiliar, GIS stands for Geographic Information Systems. GIS is usually a software that allows you to edit, create, manage, display all sorts of spatial data. And spatial data is that information that has some kind of location attribute tied to that, typically our latitude and longitude. The City of Flagstaff has been Esri customers since the early 2000s. And for water services, we still utilize ArcMap Desktop. We are on 10.7. However, we use ArcGIS Online pretty heavily. We have several collector apps, web apps, and maps, operational dashboards, and we utilize Survey 123 in some of our sections. And then for CMMS, which I'll get to in the next slide, we use ArcServer 10.6 to serve up our map services to display within our CMMS. So we have GIS. So what is CMMS? CMMS stands for Computerized Maintenance Management System. So in GIS, that's where we store all of our assets, right? Like our sewer gravity mains, our fire hydrants, our catch basins, etc. CMMS is an additional layer that we can put on top of GIS, and here we can document and track all the assets information regarding the work performed or condition scoring. So these include inspections, work orders, and service requests. There are a couple different flavors of CMMS out there. In the City of Flagstaff, we use CityWorks, and we've been CityWorks users since 2005 with our wastewater collection system. However, there's also Lucity out there and Cartograph. We've used CityWorks because it worked with our system, and I believe the cost was beneficial for us back in the day, and we just kept with them. So we have data for about 16 years now. With our collection system, we have been performing preventative maintenance on our sewer gravity mains. And when I joined the city back in 2018, I had the opportunity to implement CityWorks for our water distribution system. With the distribution system, I started with fire hydrant inspections. And then we've created work orders based off that condition scoring. And in July 2020, we decided to implement CityWorks for the open channel maintenance program. And so much like the fire hydrants, we created an inspection form. And from those inspection scores, we can create appropriate work orders. So last summer, we had a few field technicians who went out and inspected all 160 segments of open channel streams that we had in our GIS. And this process took about 3 months to do. So with CMMS, as I mentioned, there's 3 different things within that. So we have our inspection or condition scoring. We have work order management, and not listed on this slide is also service requests. So for our open channel maintenance program, we just stuck with the inspection scoring and work order management. So first we have this inspection form, which I'll show you in a couple of slides. And this form is to help keep a record of how an asset has changed over time. So you want to do an inspection to understand the current condition of that specific asset. So for open channel maintenance, what we looked at is perhaps, is there any debris in the open channel? And what type of debris is in the open channel? For other assets, perhaps like a catch basin, or maybe a fire hydrant, you could add additional information, and you can even collect other attributes for that asset that may be missing in your GIS, such as year install or manufacturer type, size, shape, etc. So on the inspection form, CMMS allows you to record all that information, and also attaches the inspector, so who performed the inspection. It has the date and time, and then the field technician or inspector has the opportunity to record additional information, such as observations, if they made any repairs while inspecting the asset, or if they wanted to record any recommendations. So on the other side of the coin are the work order management. So here you can create work orders based off of an inspection form. And so, as I forgot to mention, with the inspection form, you can pretty much say what condition that asset's in. So for open channel maintenance, we just did 1, 2, and 3. 1 meaning it's fine. 2 means that this open channel segment may need additional cleaning or needs to be looked at in the near future. And then 3, we said that the asset, the open channel stream, needs to be cleaned ASAP. So you can create work order based on that condition score. So if it's a 3, we can put a high priority work order. And there are different templates and types of work orders that we can prescribe to the inspection. So if there is a lot of overgrowth vegetation growing within that open channel, we can create a remove vegetation work order type. And then once the work order is closed, so once the work order has been, or the work has been performed, that information is stored in a database. And in CMMS, you can quickly look at the history of that asset or perform a query search if you want to look at perhaps all the open channels that have a condition score of 3, or they need erosion control for their work order type, etc. So here's our inspection form for the open channel maintenance program. So on the right hand side, or the first one, is the how clean is this channel, and that's in pink or red. So this is the mandatory field that the field technician must fill out. So the purpose of this task is to understand how clean is this channel. So as I said in the previous slide, we classified 1 being it's clean, no attention necessary. 2, we said that it needs to be looked at eventually, but not immediately. And 3 said that this channel is dirty and it may cause flooding if we were to get a monsoon. The second option, or the second little block we see here under the observations, is the debris check boxes. So we have 4 here, and the inspector can select none, or they could select all 4. So here we have trash, erosion, vegetation, and infill/dumping. And then in the comments area box, we have 3 little individual text boxes, such as observation, repairs, and recommendations. So here the field technician, this is where they can put in their field notes. And then the bottom there is where we have that priority, inspected by whom, and the inspection date. So a great thing about the inspection form is that it's very easy to customize. And so if a field technician notices something in the field that the inspection form is missing, in the office I can quickly make changes, anything from a typo, or maybe they found a different type of debris type that we should be recording, etc. So we perform the inspections first to understand the condition of our open channels, and then from there we can create work orders and assign the appropriate work to our maintenance crews. Our field technicians use Microsoft Surfaces. They have the option if they wanted to use that as a tablet or a laptop, and with CityWorks it's all web browser based. So they're just using Firefox, and then they need to have internet connectivity such as a MiFi or a Cradlepoint within the service track. And they have access to the digital atlas, so pretty much our entire GIS, in addition to all the open inspections and work orders. And for workflow, all they have to do is click on the appropriate icon, and then they can fill out the appropriate inspection form or work order form. This is an example of an open inbox map. So this is what the field technician can see. Here we have open work orders. So all they have to do is click on the red icon, and that'll generate the open work order inspection where they can then fill that out in the field. Once they open the form, this is what a work order looks like. So on the left-hand side, we have that description, and this one is remove vegetation. But this is where we can see the different template types that we have. We have all the other information like status. So is it open? Is it closed? Is the work order in progress? We have the priority level, which is in 5 different categories. So we have high, medium, low, and low. And again, the pink rows indicate what's mandatory. So we like recording the actual finish date, and then we like having who completed that specific work order. So if you recall, we collect the inspections first to understand the condition of the asset, and then from there we create a work order on top of that inspection form. So on the right hand side under inspections, you can see that this is work order is a child of the annual open channel checklist inspection with the ID of 12606. And so that inspection the work order inherits those comments from that inspection. So here, the observation in the comments on the left-hand side you can see is that there's parts of the channel that are thick with trees of various sizes. And so this field technician recommended that a chainsaw should probably be used. So this work order is associated with this specific inspection. So doing it this way, it helps record the work being done, and it's just a nice streamlined approach from pretty much beginning to end. And within work orders, there is this equipment, labor, and materials element. So you can record the equipment used, labor, so you can record the crew's time spent on completing this work, and then materials as well. So with CMMS, another advantage here is that you can carry out inspections based on condition score or debris type. And so in this example on the map, you can see all of the inspections that have a condition score of 3, and those are represented by blue checkboxes. With CMMS, you can also select a specific stream reach, and you can look at that related work history in a tabular format where you can bring that down into an Excel spreadsheet. You can also record, as I mentioned, the equipment, labor, and material costs. You can also add contractors into your CityWorks system, and you can add that associated cost for those contractors within the work orders. And then lastly, which is also, I think, the coolest part, is that if you're familiar with ArcGIS Online, you can pull that data and create an operational dashboard. So this is an example of the operational dashboard for Open Channel Maintenance Dashboard. And so you don't have to be a pro and understand GIS, asset management, or CMMS. Here, you can just give this to a project manager, a field crew member, supervisor, or even upper management, and they can easily understand the type of work, the amount of work, or inspections that have been performed on our Open Channel Maintenance program. It's pretty awesome. If you click on the icons, the dashboard is dynamic and will change based on the different filters that you select. And also, you can take that information, that data in that CMMS database, and use Crystal Reports to help generate these PDF static reports based on the inspection form. So pretty much, we're taking that inspection form and that GIS information, and we're creating this, this PDF, this static PDF that we can keep in a shared drive or print this out and put this in a nice binder just for our record keeping. So in conclusion, last year we implemented CityWorks for our Open Channel Maintenance program, and we were able to record our inspections and work orders through a digital software, and this allows us to record the history for those Open Channel maintenance. And with CMMS, we can document the type of work, the conditions, and cost, and then we can display that information on dashboards where we can easily distribute that to the individuals who want to see this information. Ed and I appreciate you guys tuning in to our presentation, and we will now take any questions.
Welcome back. Here we are right now with our presenters, and we'll get right into the questions. So the first question for Ed and Corin are basically, the first one up is, are Flagstaff's stormwater and floodplain management programs integrated? Do they handle all FEMA, EPA, and Corps of Engineers coordination?
Yeah, so we are, I don't want to say we're unique, but we're different than most municipalities in Arizona where we are coordinated and integrated. So we are a stormwater utility. We receive a utility rate from the community. So we do manage the FEMA floodplain within the city limits. So we have to work with the county on the city-county coordination where we have areas where we have water either entering the county or entering the city. Stormwater water quality we work on ourselves, and then obviously the Army Corps, the 404, 401 type permitting we do as well. So we also have our own capital improvement program, CIP program. So we have about $2 to $3 million a year for improvements.
Nice. This one's probably more for Corinne, is how were the open channels segmented to track work against them? For example, were they segmented by specific lengths, between access points, road crossings, etc.?
So we kind of had some segments from our public works when they had the program, pretty much on accessibility and the current reaches and streams that we have there. Do you have anything to add to that one?
Yeah, it's mostly based on accessibility. It's also based on parcels. So, for example, the city owns half of what we maintain. The other half are within easements. Some of those are public utility easements. Some of those are actually called out specifically for drainage. So a lot of times those easement parcels or the divisions within the parcels will help drive that. If it makes sense based on accessibility, we'll merge some of those. So if there is really only one access point, we'll merge that into one stream segment. But a lot of the times it's based on the parcel.
Okay, great. Are these considered natural streams or stormwater channels? If natural streams, what is the driver to restore them instead of let nature take its course?
That's a great question. We have both. So we have natural streams, and then we also have stormwater conveyances, so drainage ditches or swales or whatnot. And it really depends where we're at. So if it is a stormwater conveyance, then we are tasked and obligated for keeping that clean and clear. If it's a natural channel, then we usually try to keep it restored, quote unquote, to as close to undisturbed condition as we can. And what that usually means is just maintaining the sediment transport regime. So making sure we don't have excess erosion and incision, or in many cases, aggradation. So we are a community that does not salt our roads due to the lack of precipitation. So we use cinders, allow those cinders during the spring runoff wash into the stream. The stream does not have enough competency to move those cinders. So a lot of times we end up in these natural systems with pretty severe aggradation. So sometimes we have to go in and try to get something back to what it could be or should be, so that we can actually maintain conveyance and also maintain the natural environment.
Okay, great. What are the scores of 1 through 3 based on? I mean, what does it mean? What is clean? When would you need vegetation? And what do you do to make the scoring consistent across field technicians? So you basically have consistent scores across the board.
Yeah, we actually ran into that issue because Ed went out a couple of times and we had a field technician go out, and Ed was like, well, that's not a condition 3, that's really a condition 2. 1 just means it's no cleaning necessary. 2, we assumed that it should be cleaned in the near future. But 3 is like, this is very heavily debris. We did encourage the field technicians to take pictures of everything. So if we came across a whole bunch of 3s, we could see that why they may have scored it that way.
Okay, great. And you may have mentioned this a little bit, but there's 2 questions I'm going to actually combine. Is when you're dealing with, you have easements for all of your channels. I mean, what kind of notification do you have to give for those privately held properties? And then the other aspect of it is of this, a little bit different, is do water rights come into play here on the hydrology, or the stream is being altered, i.e. more runoff, less infiltration?
Yeah, great question. For easements that are on private property, especially in the backyards, we usually do a public notification, if possible, several months in advance that this is a preventative maintenance activity. So a lot of times there'll be a mailing, as well as possibly door hangers or door to door. It really depends on the amount of disturbance. So if we're talking about just cleaning out vegetation, hand crew, that might just be a month in advance, might be a door hanger and door to door. If it's cutting down people's trees, which we've had to do, so trees that are in someone's backyard, but they're on the easement and they're, destroying a retaining wall or destroying concrete, that's a little more intensive. So sometimes we will have to go in several months in advance. And unfortunately, sometimes it gets legal as well, but we make sure we have all of that cleared up. Usually through surveys beforehand. So we'll actually survey out the property lines and the easement locations ahead of time. So we have that all clarified to the best of ability. Water rights, that's a little bit more interesting. Since these are ephemeral channels, a lot of them do not have defined water rights for the truly ephemeral channels. Now, areas that are a little bit more gray, they're perennial in one way or another. We leave that up to our legal team in terms of changing flow, but it's pretty rare that we're changing flow drastically that would impact water rights at the surface level. Most of the water that's used in the city is groundwater.
Okay. Okay, with that, that's the last time we have right now for questions. Again, thank Ed and Corin for their efforts. If you have any questions, I'm sure you can track them down. I think information is available in the conference materials, but if you have specific questions, feel free to contact them, and I'm sure they'd be happy to assist and answer whatever they could.
Definitely. Thank you.
Thank you.
Now, as we move forward, move to the next presentation, a decision modeling approach to project selection. Presenters are Eddie Paulino and Joe Kratzler from the Metropolitan Water Reclamation District of Greater Chicago. So with that, let's go with the video.
Hi, ASFPM 2021. I am Eddie Paulino, Senior Civil Engineer at the Metropolitan Water Reclamation District of Greater Chicago's Construction Division. Before my current role in construction, I worked in our Infrastructure Division under my co-presenter, Joe Kratzer's Stormwater Management section. In this presentation about how decision modeling can be used in the selection of projects for capital programs, I will be going over some of the concepts behind decision modeling. I'll demonstrate their application through an example using tools available in Microsoft Excel. And at the end, I will describe a couple of insights and takeaways from our experience using these tools for our stormwater partnership programs, which Joe will be going over.
Hi there. As Eddie said, my name is Joe Kratzer, and I work in MWRD's Stormwater Management section. For this presentation, I'll provide some background, including an overview of our various stormwater programs and some of the challenges that we've been faced with over the years. Specifically, you'll hear from me about the rapid evolution of our programs and why decision modeling can be a powerful tool for prioritizing projects when given numerous opportunities. The Metropolitan Water Reclamation District of Greater Chicago, or as we call it, the District, or MWRD, was given authority over stormwater management for Cook County in 2004. Cook County is comprised of 130 suburban communities, including the city of Chicago, and is approximately 950 square miles in area. In addition to developing a uniform regulatory ordinance to ensure development and redevelopment didn't exacerbate flooding issues, our charge was to develop a capital improvement program to address regional stormwater issues related to flooding and erosion along area waterways across the county. The district initially developed detailed watershed plans which cataloged flooding and erosion problems in each of the watersheds, analyzing a variety of solutions and recommending projects to be implemented across the county. By 2009, we had completed some of the watershed studies and began designing regional stream bank stabilization and flood control projects, establishing partnerships with other agencies and local governments along the way. These projects, many of which had been constructed while others are still in design, range in size from $1 million to $65 million, totaling nearly $400 million in construction costs. While these projects provide benefits to dozens of communities and protect thousands of homes and businesses from regional flooding and erosion, local communities were still facing significant stormwater challenges related to local or urban flooding issues beyond the reach of our statutory authority. The district recognized that our authority was limiting the ability for us to assist local communities in addressing significant issues related to stormwater runoff in urban areas. And in 2013, went back to our state legislators and successfully lobbied for an expansion of our statute. In September 2013 and August 2014, respectively, our Board of Commissioners authorized the district to assist local communities in addressing flooding through partnerships for local stormwater projects and flood-prone property acquisitions. In 2015, the district also adopted a Green Infrastructure Program plan. These new initiatives led to the development of our Stormwater Partnerships Program, through which the district has partnered with dozens of local communities and agencies to implement projects across our service area. Over the last 6 years, as our stormwater program has continued to expand, we realized that we need to develop tools to help us better prioritize our project selections and ensure we're maximizing the use of our funding to get the most benefits for our constituents. Since 2004, when MWRD received its Stormwater Authority, our program has evolved significantly. As you can see on this slide, we've evaluated approximately 470 stormwater projects across our various programs and added over 180 projects to our overall capital stormwater program. In order to develop a structured stormwater partnership program, MWRD initiated an application process for our green infrastructure, local stormwater projects, and buyout programs. A schedule for each program has been established for project solicitations from local communities and agencies for these programs, and has evolved into annual calls for stormwater partnership opportunities with the district. Upon receiving application submittals, the district reviews and prioritizes the projects for potential district assistance. The prioritization process requires a review of the project costs and their benefits. These include the number of benefiting structures, the cost of the project, median income of the project area, and several other factors depending on the type of project. Ultimately, the number of projects that can be selected depends on the annual budgetary allocation for our overall stormwater program and the project schedules. We've used numerous H&H models and optimization tools to assist us in identifying solutions to flooding, but modeling can also be especially useful in decision-making that involves large amounts of information like our growing portfolio of stormwater partnership projects. As our stormwater programs have expanded, combining all the prioritization factors in an ever-growing data set has become a challenge. Fortunately, we have some very smart engineers like Eddie Paulino who are helping us to make more informed decisions on the projects we add to our capital improvement program. Eddie?
Thank you, Joe. Before I get into the example, I would like to show you what the process of decision modeling involves. What we're trying to do is we're trying to create a mathematical representation of reality. We start by finding a problem we're trying to solve, then formulating it by gathering the relevant and available parameters, making assumptions, placing in constraints, and adding the mathematical relationships. From there, we perform our analysis. In the case of project selection, we will be optimizing the linear program to maximize the total benefit our organization produces with the project selected. We then interpret our results, perform sensitivity analysis to see the impact of changing constants, and finally, we can incorporate risk by adding uncertainty into our problem parameters. We then interpret the results and see how well it matches reality. If it does not make any sense, we start over again in this iterative process. Okay, so now let's get into our example. When working with these spreadsheet models, it's useful to use a color key to identify important cells in your formulation. In blue, we have our decision variables, or what we're changing. For example, we're changing, in this case, the funding contribution our organization is providing across 4 stormwater management projects. In yellow, we have cells that are used in the formulation, which can include constants and multipliers like a discount rate, used to calculate life cycle costs, or multipliers used to assign a point structure to parameters like the number of benefiting structures or the median household income of the project community. In green, we have our objective function. In this example, we're using 2 selection criteria. Life cycle cost divided by the number of benefiting structures or structures being removed from the floodplain, which is scored from 0 to 10. The median household income of the project's community, which is scored from 0 to 5. We add up the score for the 2 criteria and multiply the total to get a project score. We then sum the scores across all our projects. This formulation makes it so that the benefit of the capital program increases the more we fund higher score projects. In red, we have our constraints where we are making sure that we do not exceed the number of available staff man-hours to manage the projects, as well as the budget allocated to our stormwater partnership programs. The next step in this process is to enter our formulation into our tool, Microsoft Excel Solver. And Solver is a standard Excel add-in that was developed by Frontline System. It comes with your Excel installation free. It can be turned on by going to the add-in settings, then clicking on the checkbox to enable the feature, which you see on the screen here. The tool then shows up on your data ribbon in Excel, titled Solver. This tool allows us to maximize, minimize, or force our objective to reach a specified value. We can use inequalities to enter in our constraint relationships. We also use the most common constraint, which is the decision variables can't be negative, which prevents us from borrowing from a low score project to fund a higher score project. The optimization method we are using is called simplex method for our linear program. The simplex method to solve a linear program can only be used when your objective and constraints are linear functions of the decision variables. It works by checking the impact on the objective when making small changes in each variable. It then exhausts each variable in order of impact until all constraints are met. Linear models guarantee that the solution is a globally optimal solution, or in other words, the best possible solution in our problem. Solver also provides reports for linear models that do some of the sensitivity analysis you would have otherwise had to do yourself. The most insightful report is the sensitivity report, which gives you what it calls a shadow price, or the amount your objective changes as you shift one unit of a constraint one way or another for an allowable range. A sensitivity report can tell you, for example, that by increasing your budget or your staffing levels, you are able to fund an additional amount towards a project or an additional project in your program. Another tool for sensitivity analysis, and this one developed by professors at Indiana University, is data table. You're able to run the optimization by changing 1 or 2 parameters at a time. Here, I am changing the weight of the median household income score and the weight of the life cycle cost divided by the benefiting structure score. That's my 2 criteria that I'm considering for this project selection example. This tool essentially allows you to test the impact of your assumptions by changing the assumptions and seeing how the results change. Now, if you are unable to formulate your problem through a linear program, Solver also has two nonlinear solving methods: the generalized reduced gradient GRG nonlinear and the evolutionary method. The downsides of using these methods is that your solutions are local or basically not guaranteed to be globally optimal, and it can take much longer for the computer to run the solving algorithms. To consider uncertainty or risk in your problem, we can use a Monte Carlo simulation analysis, which works by assigning probability distributions to problem parameters and running many simulations to see how the uncertainty impacts your results. An example of how we have thought about using this analysis in our project selection is to consider the likelihood that a project is able to move forward if MWRD commits to providing funding for the project. We would assign a % chance that a project can start construction its budgeted year based on the historical data on the partner community staffing levels, their annual budget, or how far along the design of the project is at. The analysis essentially works by rolling a weighted dice one time for each simulation for each probabilistic parameter. We then would run thousands of simulations and see how the results change. What would you expect to learn from performing the Monte Carlo analysis on an example like this is that a lower score project may be a better option to fund on a given year if it has a higher likelihood of moving forward than a higher score project. The results of a Monte Carlo simulation analysis can provide to you confidence intervals that tell you, for example, that there is a 90% chance that you'll be able to utilize X number of dollars on a given budget year with the projects you are considering the stormwater management partnership programs. All right, so we know practice makes perfect, so let's go through one short example. The problem here is what to order for dinner. The decision variables are restaurants near my house, and my constraints are going to be my budget and the distance that restaurants are able to deliver. For my objective, I'll be maximizing the score that will be given to each menu option by considering the cost, my personal preference based on what I've been eating throughout the week, the popularity of the restaurant, and customer review ratings on Yelp and Google. I'll then run my solver and check my results. Oops, it looks like I forgot to incorporate some of the health parameters into this decision model. This example illustrates the commonly used phrase you guys have probably heard with everything going on with COVID and COVID modeling, which is that all models are wrong, but some are useful. And you make these models useful by going through this iterative learning process. In this case, I could have added some constraints limiting my daily intake of certain nutritional components based on FDA recommendations. Okay, so we have discussed how decision modeling tools can be used for project selection, but there are many other decisions that these tools can be used for, including workforce scheduling to determine whether overtime or hiring new staff is optimal. You can use it for budget and revenue management to maintain a consistent cash flow with the initiatives undertaken. You can also use it in materials procurement to optimize if buying and storing materials now is more cost effective than buying materials when they are needed. And you can even use them for personal decisions like home purchases or even equity investments. Now I'd like to go over a couple of the insights and takeaways from our experience working with these decision modeling tools. For the first point here, you have to consider the subtle meaning in the formulation. For example, maximizing flood reduction may lead to a complete different result than minimizing flood risk. For 2 here, if the flood reduction benefit is based on property values, these models will prioritize projects in higher income neighborhoods, even if the ultimate impact is lower. On number 3, you have to avoid limiting your selection to projects that can be completed in short outlooks. Projects funded over multiple years are worth considering in the comparison. 4, consider the life cycle costs and benefits of project alternatives using a discount rate to calculate the present values. Without a life cycle cash flow analysis, you may be missing the impact of maintenance schedules and depreciation may have on your project evaluations. For 5, think about how the rain barrel program, reimbursement program compares to constructing a large reservoir. Think about how a property buyout may be cheaper than a flood control project. These are questions you can answer if you compare across the organization's initiatives. On 6, don't forget the Do Nothing project because it has costs you do need to consider. 7, if our organizations are working in the area, if other organizations are working in the area, you may have overlapping projects. Try to coordinate to avoid seeing road work happen twice in the same year. Once for your sewer, maybe the second time for the community's own road maintenance efforts. 8, use economic cost data whenever possible, but don't shy away from the qualitative data like the ratings that I discussed in my earlier examples. 9, consider equitable distribution of your efforts. Be sure your prioritization of resources is focused on high-need areas. 10, decision modeling heavily relies on accurate and complete data sets. Old project records can show how your current selection compares to previous years. 11, the feedback other stakeholders like community members, partner agencies, private companies provide will help you cover your blind spots. And the last one here is to not leave business decisions to intuition. Decision modeling gives you a great opportunity to take a data-driven approach to solving your business challenges. Plenty of other industries implement these sorts of tools every day in their operations, from sports teams optimizing their player selection to airline scheduling flights to avoid empty seats. There are quite a lot more specialized tools that we've used and that are available out there in the realm of data analytics, but considering the low barrier of entry, these Excel tools I talked about today are an effective and very empowering starting point for any organization. If you'd like to learn more about our stormwater management partnership programs or our project selection practices, please feel free to contact us directly or visit our website linked on this slide. Thank you.
Welcome back. We have with us now the two presenters, Eddie Paulino and Joe Kratzer. So let's get into the questions. First up, during the presentation, you mentioned household income as an area is a factor in your decision-making of project selection. Can you explain how that works?
Sure. Eddie, you want to start off, or do you want me to go into it?
I can. It's been a while since I've looked at one, but I know we've kind of been developing these models, and it's kind of changed. I know the first model for our phase 2 program, we use it as a way of kind of like a declining scale where we funded the lower the medium household income, the higher the funding for that community the project received. But I do remember on our green infrastructure program, we actually use a scale from 1 through 5, depending on the household income. So there was ranges, and that score was given a weight that was then used to prioritize funding for those projects. Those are kind of 2 approaches that we use. But yeah, Joe, you can go ahead if there's anything else that's changed since then.
No, it really is kind of been an evolution. We've considered household median income as kind of a good indicator where the impacts of flooding are probably seen the hardest. And we have, also looked in our project prioritization process. I should say we've looked at median income in 2 ways. One, in our prioritization process, and that's kind of like I described with our green infrastructure program, where we kind of have a lot of different factors that we evaluate through the projects that are submitted to us. And I think, as mentioned earlier, we have a pretty robust application process. I don't want to say robust. We try to simplify it as much as we can, but it's evolved into something that we're allowed to look at many factors, and median income seems to be a good factor to look at when we're selecting projects, because we know that our money will be spent in areas where, like I said, flooding impacts are seen the worst. But also when we do select the projects, then we have to determine how much funding we can put towards those projects. And then we also add in income at that stage too. So we kind of do it twofold.
Okay, along the same lines, and if you saw the plenary session, one of the topics that was asked about or was discussed with David Marstead with FEMA is, the consideration of factors in equity. And to a degree, in your decision making, the household income definitely is a factor in that aspect of it. But are there any other factors or considerations that are currently taken or input in to address equity issues? If yes, what are they? And then if not, are there considerations for future? Is there something in the future that you're going to think about considering, or are you looking for potential top ideas for those factors to address equity issues?
I was going to mention, Joe, just the one example used in the green infrastructure relating to, I know equity can be looked at in different ways, but in terms of where our funding has been going in terms of the communities that the projects have been awarded to, one of the factors that has been considered in one of our previous models for our green infrastructure projects is that is considering the past funding decisions we've made and maybe prioritizing projects, giving it a factor based on whether that community has been funded in the past, so that making sure that we're funding, the funding is going towards multiple communities if there's a need for those communities. So that's something we've considered or that we have used in our model so far.
Yeah, and actually kind of building on that, one of the things we've done that really is kind of hard to work into this decision modeling, but it's kind of beyond the scope of it, but it kind of gets to the same point, is we know that certain communities have a lot of capacity to submit projects because they've done planning on their own, or they have other resources available to them to identify projects. So like Eddie said, if we've selected projects in a community in a prior round, whether that's through our local stormwater partnership program, our green infrastructure program, or our buyout program, we want to take that into consideration and try and spread those projects around. And the other way that we're kind of addressing equity is in recent calls for our local stormwater program, which is really geared towards addressing urban flooding, kind of those flooding problems outside the floodplain. We're looking at what we did a year ago was we just requested projects that were kind of shovel-ready projects. And then in this most recent cycle, we asked for communities, and we really were trying to focus on those communities that had the highest need, to identify areas where they know they have a flooding problem but haven't identified a solution yet. And so we're calling those kind of conceptual projects, where, again, there's a problem but not a project yet, and we can actually help those communities that don't have the resources develop a project. We may be able to, depending on the situation, take that project all the way through to design and construct. But in other cases, we're looking for communities to take an active role where they have some capacity somewhere along the line. So in some cases, we may develop a project or maybe multiple projects. There may be multiple alternatives worth pursuing, where those communities can take those conceptual projects that we do the preliminary engineering for, and actually go after grants from other state and federal programs. So that's kind of another way we're looking at addressing equity issues. And again, we acknowledge that probably nationwide, but especially what we've seen in the Chicagoland area is that the hardest hit areas typically have a lower median income and have other socioeconomic challenges. And we're doing, we're kind of attacking it from multiple fronts.
Okay. As far as, and I'm going to go off script here from the questions, kind of following up this. You mentioned green infrastructure projects in those lower social economic areas. Have there been, like, and any integrations of community gardens and operations like that with your programs that to provide some additional resources to the communities, and then also just creating green open space for recreational or just a natural experience, some sense of natural, something other than the typical urban concrete areas that many of the lower economic and lower income communities in Chicago typically have.
Bill, that's a great question, and I think when we first started out with our green infrastructure program, we were kind of looking for the low-hanging fruit. The impetus for the program was a consent decree requirement that was included in our decree. We were charged with creating 10 million gallons of design retention capacity in the form of infrastructure in about 15 years. We did it in about 6, and now it kind of frees us to kind of be a little more creative with some of the end use, if you will, of those green infrastructure sites. So early on, we did a lot of green alleys in the Chicago area. We're still doing those because they do provide a meaningful benefit. But we are looking at other projects. In fact, we're looking to partner with a broader base of government organizations in the area, not just with municipalities and public works departments. We're looking also at park districts, forest preserve district, and other entities where we can provide a little bit more than just permeable pavement where there was some asphalt before, some improved outdoor space. In fact, in the city of Chicago, we've got a program. We're looking into partnering with a couple different departments there to turn vacant city-owned property into green space. We don't have a good term for them yet. We kind of loosely call them stormwater parks, but those are some of the ideas. We have had a couple other projects where they incorporated community gardens around them as well. Like you mentioned, that's a great opportunity to kind of bring the public to those sites, and we always have a lot of signage and educational material about the benefits of green infrastructure. So trying to do our best to promote it throughout the county in a multitude of different ways.
Okay, great. As you work in the district itself, you're not really the FEMA NFIP entity, but you do work closely with FEMA. How do you work with the communities, or have you integrated communities' issues with repetitive loss or severe repetitive loss properties? And have you integrated those in and prioritized them in your models? And then if you have, have you had success with those opportunities?
So just real quick, most of our focus on severe repetitive loss and repetitive loss properties is focused around our buyout program. We've done quite a few buyouts, mostly around the regional, larger regional waterways like the Des Plaines River, Chicago River, but we've also done some on some of the smaller tributaries. And wherever we can find a community willing to sacrifice property, and they're going to see a little bit of a loss in their tax base. I mean, we really laud those communities that are willing to take that.
Okay, well, great.
Leave a little time for
all we got time for questions. I appreciate your participating here, and again, thank you. And we'll move on to our final presentation for this session.
Thank you.
The title of that is Flood Mitigation in an Urban Environment, Cypress Street Outfall Regional Stormwater Improvements in Tampa, Florida. Presenter is Michael Thatcher with Tetra Tech. So with that, we'll start the video.
Hi, my name is Michael Thatcher, and I'm a civil engineering group leader and project manager with Tetra Tech. At Tetra Tech, we are leading with science and on the cutting edge of providing industry-leading technologies to deliver for our clients. Today, I'll be presenting a successful flood mitigation case study by highlighting the City of Tampa's Cypress Street Outfall Regional Stormwater Improvements Project and how we are nearing the successful implementation of providing large-scale flooding relief to this urban environment. Here, you'll see a brief clip depicting the project's location. Our project is located within the West Riverfront, North Hyde Park, and West Tampa neighborhoods, and is adjacent to Tampa Prep School, Julian B. Lane Park, and the University of Tampa. So first, I'd like to start off with the problem. As depicted in these photos and articles on your screen, the city is no stranger to intense storm events. Intense rainfall in a highly developed urban environment can be a predominant cause of major roadway and property flooding, where a lack of adequate stormwater infrastructure can only exacerbate the issue. Heavy rainfall causes high-velocity overland flow, which can result in stormwater facilities exceeding their capacity. The city has been plagued with large-scale flooding due to heightened rainfall intensity, sea level rise, and a lack of critical infrastructure. Our project objective is simple: to reduce major roadway and property flooding within this 220-acre, highly developed urban watershed. So the first step for this project was setting our project's limits. The limits were determined based on previous studies and conceptual modeling efforts, records of historic flooding, including repetitive lost properties. On your screen, you'll see the red outline depicting these limits, which are bound to the west by West Gray Street from Tampania Avenue east to North Rome Avenue, north from North Rome Avenue at Kennedy Boulevard to Cass Street, and from West Cass Street east to where we tie into existing infrastructure at the intersection of North Boulevard. In total, these limits encompass approximately 1.5 miles. The existing infrastructure we tie into are twin 9-foot by 7-foot box culverts, which travel along North Boulevard and discharge near Julian B. Lane Park. Once we had set our project limits, a team of skilled land surveyors obtained all necessary topographic and subsurface information for use in the modeling and design of this project. For this project, we utilized XP Swim for the stormwater H&H modeling, a product developed by Innovize. We utilized a 2D model, which means rather than just looking at the routing of links and nodes within the project area, think links and nodes as pipes and structures. We also look at the surface aspect and how water travels relative to the ground topography. Below is an example of a link and node schematic. Once our project limits have been set, we can then perform a basin analysis to determine the limits of the contributing watershed. The existing watershed, including subbasins, are depicted on your screen. The design storms we evaluated for this project were based on a few things. First, we needed to meet permitting requirements with the Southwest Florida Water Management District, who is the jurisdictional review agency for stormwater environmental resource permitting for this project. This required we design the system to the 5-year 24-hour storm event. We also evaluated the 25-year 24-hour storm to review the implications of heavier rainfall and its effects on the proposed box culvert system. Lastly, we evaluated the mean annual storm to provide a baseline for a more average storm event. Intensity, duration, frequency graphs were utilized from the Florida Department of Transportation's Drainage Manual, including hydrographs and rainfall intensity curves. Also shown here is FDOT's depth, duration, frequency curve to determine the total depth of rainfall for the desired storm event. Once we input our existing infrastructure and assign necessary conditions to the model, we then reviewed the existing conditions results to verify the results closely matched that of known conditions, again going back to the records of historic flooding. On your screen, you will see the outputs for the 3 design storms modeled for this project. As you can see, there's a large concentration of water staging along the central portions of Gray Street to the west and North Rome Avenue to the south. As I flip through, you can also see that the estimated staging levels are increased as the storm intensity increases. Once we are comfortable with the existing conditions modeling results, we then develop the proposed basins. Here, you'll notice that the number of basins increased by about 3-fold, based upon the proposed increase in stormwater infrastructure. Since we're proposing additional inlets in the proposed conditions, there are now more places for stormwater to enter the box culvert, therefore cutting down on the size of the proposed basins. We then began inputting proposed links and nodes into the model. We began with sizes which were evaluated by other consultants in previous studies. Once these were input into the system, we evaluated the size of proposed box culverts in an effort to optimize the system and provide potential cost savings. An example is shown below, where different runs of box culvert sizes were compared for the 5-year, 24-hour storm event. Another example is shown here on Rome Avenue, where we evaluated and compared between a 5-foot 10 box and a 5-foot by 12-foot box culvert shown for the 5-year, 24-hour storm event. In total, Tetra Tech performed 7 different sizing iterations along the proposed trunk line to optimize the box culvert system. Here's a snapshot along the downstream roadway, West Gray Street, where we proposed twin 8-foot by 8-foot box culverts. Although the Southwest Florida Water Management District only required this be designed to the 5-year, 24-hour storm event, Tetra Tech and the city were cognizant of the effect that too small a culvert could have on the project's cost-benefit ratio when evaluating larger storm events, such as the 25-year, 24-hour storm. Shown below is an output of the proposed conditions modeling results. As you'll see, the flooding depicted in the existing conditions results is greatly reduced along West Gray Street and North Rome Avenue for all 3 storm events. So now we'll move into our design approach, including some constraints that were evaluated. Some of these constraints include a flat grade along the project corridor, various super elevations within the road which were not conducive to drain water, a lack of existing inlets, as well as a confined right-of-way. The picture to the right gives a glimpse at the flat existing grades, many of these set near 0%. We designed these roads to have positive drainage to all inlets at proposed low points, as well as secondary inlets along the roadway to reduce the spread of water into the road. We did all of this while being cognizant of the narrow footprint to ensure we could tie in all grades within the right-of-way. In addition to the design of the regional box culverts, we also designed all of the secondary stormwater infrastructure to connect to the proposed culverts. This included over 3,500 linear feet of stormwater pipe as large as 54-inch, and over 220 stormwater structures, including inlets, access manholes, and junction boxes. Lastly, we designed a full roadway reconstruction to improve drainage patterns along the roads and implemented stormwater best management practices to aid in water quality. So besides stormwater, what else did we do? This roll deck will give you a visual of the additional services we provided on this project in the order they were constructed. They were constructed in this particular order to reduce the number of utility service outages. Now, obviously, considering the design constraints, this was quite the undertaking to fit within a 50 to 60 foot right-of-way. And below is a detailed list of these additional services, which included over 5,600 linear feet of sanitary sewer improvements as large as 24-inch, 9,600 linear feet of potable water distribution improvements, 6,500 linear feet of new 36-inch potable water transmission main, and included multiple major utility relocations, as well as a suite of multimodal improvements, including new sidewalks, bike lanes, and a two-way cycle track to connect to the Green Spine cycle track, which is being implemented in other locations throughout the city. And as you can see, the confined right-of-way is an understatement. Being as narrow as 50 foot, many of the existing buildings along the corridor front directly adjacent to the right-of-way. Based on the size of the contributing basin, over 220 acres, this project has the potential to impound upwards of 450 cubic feet per second of water into Tampa Bay and the Hillsborough River. Tampa Bay is impaired for dissolved oxygen and fecal coliform. So what did we do about it? Some of our solutions included the implementation of second-generation nutrient separating baffle boxes, which help to remove suspended solids, as well as the utilization of Bold and Gold media cartridges in these baffle boxes, which aid in reducing nutrients like nitrogen and phosphorus. Also included was the addition of pervious pavement to aid in groundwater recharge, inlet skimmers to catch floatable materials, and grass swales to aid in water retention. Here's a map that depicts some of these improvements, with 4 proposed baffle boxes shown in blue, pervious pavement areas shown in pink, and grass swales shown in green. This project was advertised as the design build construction method. So why design build? Design build projects aid in providing an expedited process, meaning their speed of delivery to the client. It also provides a collaborative team-driven process where the contractor and engineer work hand in hand from the beginning of design. It can also eliminate some oppositional conflicts which can be found in standard design bid build projects, and can result in cost savings by identifying constructability issues early in the design process. Our project schedule was streamlined in an effort to condense the time between notice to proceed and construction completion. Shown below is a summary of the project tasks and milestones. As you'll see, we went from design notice to proceed to construction notice to proceed in less than 1 year, which for a project of this magnitude is an impressive undertaking. But why so fast? The City of Tampa had secured project funding from the Southwest Florida Water Management District and had a district approval date which could not be extended. The design build team was able to meet that date and obtain unanimous approval to commence with construction. So how much was funded? In total, the Water Management District provided 50% matching funds. When combined with the city, approximated to $35 million. This was completed in the form of a cost share agreement. Tetra Tech partnered with Woodruff & Sons, a general contractor, to implement both the design and construction of this project. So how's construction going? Construction began in August of 2019 and is expected to be complete in November of this year, both on time and on budget, which is especially important for a project with a cost-sharing agreement. So now I'll flip through some progress photos of construction so you can get a better idea of the magnitude of these improvements. Here's a Jeep for scale next to one of the 8-foot by 8-foot box culverts. Remember, we had 2 of these in the ground right next to each other. One thing I had previously shown on our slides was the historic significance of the project area. We were able to successfully blend a new design with the historic elements of the neighborhood. These photos give you an idea of the project's magnitude. For a better idea of scale, this is at the intersection of Rome and Gray, where we have an excavation for a future junction box where a 5-foot by 10-foot box and a 7-foot by 10-foot box will tie into two 8-foot by 8-foot boxes. This hole is close to 40 feet by 40 feet and over 20 feet deep in the middle of an urban intersection, which is pretty impressive. Here's a photo of that same hole a few weeks later, about to pour the top slab for the junction box. Notice the residential construction in the background. As you can see, large infrastructure means large machinery. A majority of construction for this project occurred during the COVID-19 pandemic, which, as you can see, was a safety priority for the project team. Here's a few photos of the two-way cycle track. You can notice the median opening to the left for stormwater to enter the inlet. As you can see, existing brick was repurposed within the cycle track traffic separator in an effort to maintain historical elements. And here's an aerial shot showing how traffic was maintained to safely construct these improvements. And a few more aerial shots showing pipe laying, then regrading, then the final product along this stretch of Cass Street. And as you can see, there's some good press. Thank you so much for your time. And now I'll open it up to any questions from the group.
Welcome back. Here we're ready to answer any questions that you've submitted with Michael Thatcher. So with that, we'll get to our first highest priority question. There you go, Michael. Were less recurrent events beyond the 25-year event analyzed? Do you know what the impacts of a 1% chance event would be? And was the design limited to the 25-year event due to policy, funding limitations, or some other factor? So a lot of questions.
Yeah, great question. To start, yes. So one thing I did not include in my slides, but is worth noting, is we tied into a state road with these improvements. And what the Florida Department of Transportation requires is that you run the 48 critical storm analysis, and it's essentially 48 different design storms that you input into your model. And so this analyzes everything from the 1 year, 1 hour, and 1 year, 24 hours, all the way up to 100 year and beyond. So we really looked at the full suite, but those three that we listed, which were the mean annual, the 5-year, and the 25-year, were all most important because we're trying to look at more of a common occurrence storm as well as large scale flooding. So we could sort of size both the box culverts and the secondary storm system to account for both. Okay.
Presuming your outfall was a tidal outfall, was the design modeled during high tide conditions? Were there tide gates? And if there are no tide gates, would this new system allow for hurricane storm surge to backflow and penetrate deeper into the city?
Yeah, so great question. Sea level rise was certainly a consideration to use here. The outfall fell on the Hillsborough River, but this ties directly into Tampa Bay, and therefore we were tidally influenced. So one thing that we looked at was we tied into an existing system. I had mentioned there's a 9-foot by 7-foot dual boxes that were already implemented, and those did include implementations for tide. And so when we tied into that, we also analyzed that ourselves just to make sure that any storm surges in the future, looking out into NOAA's 2100 year projections for the mean high water projection, were accounted for in our design.
Okay. As far as from a design consideration, are the design storms based upon Atlas 14 data?
Yes. So we, again, going back to the DOT requirements, the Florida Department of Transportation has their own drainage manual, and this is followed by most states. To make this a short story, yes, DOT does follow that. And so by default, we were utilizing that in our model.
Okay, great. For areas where permeable pavement was installed, was there any consideration of impacts to utilities?
Good question. Yeah, so one thing that we considered was the parking limitations of what types of vehicles can park on this pavement and the level of service of the pavement itself. Clearly, since it's more porous, it generally is slightly weaker than a rigid or flexible pavement cross-section. So one thing that we did look at was placing our critical infrastructure and trying to avoid placing it beneath the pervious pavement. That included the box culverts, that included the 36-inch transmission main as well.
Okay, great. Next question was, does the project use any structures or holding basins to account for the increased velocity, volume of the stormwater to avoid erosion at the outfall locations?
Good question. So the first measure, most downstream, would be the tide gates, which do allow for, if there is a high tide, for water only to exit as much as your head can allow. But one thing that we implemented in all of our individual stormwater structures were sumps, which allow for sediment in smaller storm events to settle out prior to it discharging downstream. To manage the velocity in the large box culverts, we did look to minimize slopes of these boxes. And what we ended up doing at the downstream sections, we actually set these box culverts at a slope of 0%. And the goal here is that we size them to convey at this flat slope, yet at the same time still reducing the peak velocities flowing through these boxes.
The follow-up to that were there any other considerations to address downstream impacts?
Yep. Again, we certainly looked at these things, and we did a full model to confirm the sizes of everything within our project's limits. But since we were tying into an existing system, those measures were already implemented, and something that was tied into.
Okay. Not as much as a technical question, but how was the community involved in the project design?
Sure. Yeah. So we had a public involvement sub, which coordinated with the public on a very regular basis. We also had public meetings with the public, both in design, pre-construction, and then also we've had one or two in construction themselves. The public has been generally great. I know you guys saw some of the photos on your screen. We were tearing up some pretty busy intersections, and they were completely closed off. So considering the amount of impact these guys were facing, they have been excellent to work with so far.
Okay. From your presentation, the person who submitted the questions observed that the construction photos look dry. So shallow groundwater wasn't a problem. So was there basically groundwater issues or, other issues that really had to be taken into consideration?
Yep, great question. Groundwater was high, and what you're seeing in these photos is generally for the large boxes that were put in the ground, especially that junction area where we had those large boxes tying into one another. That was dewatered for weeks prior to make sure that they had plenty of depth to set their bedding stone foundation and then set the rebar, because they do need a dry trench for that. But in general, groundwater varied likely between 3 to 4 foot below ground and maybe as deep as 10 foot in our higher reaches.
Okay. And then one question here is, I think you answered, is how long would it take to get this from concept to implementation?
So yes, our part in going from the start of final design to the beginning of construction was 1 year, but the program itself was much longer than that. This is a capital program from the city that's over $300 million in total. This is a small part of that, about an eighth of that total amount. And so this was master planned back in 2009. It was conceptually permitted back in 2013. So what we did is we took a section of that from conceptual permit to final design, final permitting, and construction administration.
Okay, with that, we've ran through all the questions. So I want to thank Michael for his presentation. I want to actually thank all the presenters this afternoon for this session. We're getting close to wrapping up this session. In fact, we're wrapping it up right now. With that, I thank everybody who looked in on this. Remember, there's still another session that'll be following up in about 30 minutes. And in those 30 minutes, if you're looking for something to do after you check your email at home or at the office, think about dropping into the exhibit hall and wandering around. There's several of our vendors and firms that are be happy to talk with you about the services they provide or show you the projects they're working on. So with that, I thank everyone and wish you a good afternoon, and hopefully you check back in at the exhibit hall or at the next session. Thank you.
Thank you, Bill.